Hey everyone, so I know I'm missing the first couple videos in 6.2, and that's because I typically lecture these live. I really like the interactive experience, but of course we don't have a Zoom lecture, so they're missing from your guys' practice quizzes, so here they are. They're mostly about feelings and how they're related to confidence intervals. So we start out with just sort of like, hey, what's your guess for the proportion of students who are left-handed? So I'll typically ask this of the class, and I'll get a variety of answers, anywhere from like 10% up to like 40%. So let's just assume that we're going to go with some random guess that has been thrown out, and we're going to say that we think the proportion of left-handed students is around 20%. And we should do something to say that this isn't the real P, which we denote with a P, but it's some guess at that. So we can either put a hat on it to say it's our guess. Typically that means sample value, and this isn't technically a sample value. So let's just call this like a star or something to be like, this isn't the real deal. Then we get into the idea of, well, what if you took a sample and you had the number of people in that sample who were left-handed? So if we took a sample, we can go ahead and calculate a sample proportion, which is just our x over our n, the number of people who are left-handed out of the number of people we sampled. And then we could use this as our estimate of the proportion of people who are left-handed. And we could do that again, except for this time with a bigger sample. So now our p hat is 165 out of 1,000. And the question I always ask my class, and it seems silly, but again, we're in the feelings land of 6.2, is which of these do we feel the best about? Which of these will we feel the most confident about? And everybody always says the last one, and the reason why is because we had more information, right? The first one was just a shot in the dark. We didn't really know anything. Second one, we had 100 people. Third one, we had 1,000 people. We had 10 times the amount of information that we had in that from that second estimate. So keep this in mind. This is why when we're calculating a confidence interval, we need more than just one value to estimate it, because with one value, I can make myself seem really accurate by just adding more decimal places, right? If I said I think the proportion of left-handed people is 0.1732, you're going, oh, she must have a lot of information. And in reality, I'm just making up numbers. So we need a way to show that certainty. And that's what a confidence interval allows us to do, to have a point estimate as well as a margin of error, like how much error we could expect around that estimate. And then we get our reminder of this really outdated exercise that I put in my notes back in 2010 when I first started teaching. The CNN estimate of the proportion of people who were going to vote no on Prop 19, which was the legalization of marijuana back in 2010. You can see here we have 53% opposed to Prop 19. This 53% is a P, right? But we also have a P down here of 54%. So this is our first time in Chapter 6 of dealing with competing P's. Actually, I guess we kind of saw it in 6.1, but only in the very last example. But we're going to see this a lot when we get to 6.4. So it's important that we pay attention here. Wherever our sample size is, that means that that proportion that was given there is the sample proportion. It should be a p hat. And so in this case, the parameter, the thing that we were hoping to estimate, was the true proportion of people who were going to vote no. That's the 54%. And we're comparing that to our statistic, the sample proportion of people who voted no, which was this 53%. And so on the surface, the CNN poll does not seem bad, right? We did a decent job. The two values are pretty dang close to each other. But I'm going to tell you right now that this confidence interval is a hot mess. It's garbage. So if we actually go and create this confidence interval by using the formula that's up above, taking our point estimate and adding or subtracting a margin of error, well, we'd start with that 0.53. They did give us a margin of error. They said our margin of error was 3.5%, so we can add or subtract that. I'm just going to go ahead and make them decimals because we typically live in decimal land here in proportions. And so we could make a confidence interval. And when I ask you for a confidence interval, I do want this given as an interval. With mathematically is going to be the lower value and then the upper value. So you're always going to subtract and then add. So if we do the math here, our lower value is 0.495 and our upper value is 0.565. So this is the first time we would interpret a confidence interval, and I typically ask my class, what do they think this means? We now know, if you've gone a little bit further, that there is a set interpretation that we should be using. Um, for now, I'm gonna pretend that we don't know that interpretation yet. I'm gonna write down what I would typically write down in my class as we talked about this. And so rather than use the real words, which are that we are blank percent confident, yada, 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 we'd say something like, we think the real proportion of people voting no is between 0.495 and 0.565. And you could even get rid of the real proportion thing and just say we think 49.5% to 56.5% of people are going to vote no on Prop 19. So again, in one way, the CNN poll is actually good, right? If we look back at what the actual value was, that's not a highlighter, 0.56 or 0.54, that is actually in this value. So CNN was correct, right? But if we look at what this conclusion is saying before the vote, it's not saying anything at all. Because if 49.5% of people vote no, that means it passes. And if 56.5% of people vote no, that means it fails. And one thing we're going to learn about confidence intervals is it doesn't matter that the majority of my interval is in the fail realm, right? It just matters that we don't know what our value is, and it could be that it passes and it could be that it fails. So on the surface here, even though we did actually capture the real value, the CNN survey, the CNN poll, told us absolutely nothing about what was going to happen with Prop 19. This was a useless margin of error and estimate for us. I actually chose it on purpose because I was going through, back in 2010, a Wikipedia page of all the different polls that had been done, and this was the one that included both passing and failing, and I was like, yes, I will include that one in my notes. So that's the start of the feeling section. I'm going to break this up because I don't believe in a video longer than 10 minutes, and I'll give you a second video for the rest of this missing material.